Hello guys, in this video we will be learning how can we make a Bluetooth control card using ESP32. Firstly, we will be taking a Bluetooth receive node for receiving data. We can change the setting from here. Here the output will be the received data, and then done. We will compare the received data with the key A. Check if equal. The string 1 will be the received data. The string 1 will be compared with the string 2, and the output will be the result. If the result is equals to A, then it will display left. If the condition will be equals to our result, then it will display left. The motor will rotate in a left direction. Display left. Update it. We will be having a DC motor. We will be changing its setting from double tapping on it. For motor, add new DC motor configuration. It's a 2-pin mode, so we will be selecting 2-pin. Pin 1 is 2 and pin 2 is 4. Add. For the Bluetooth card to be rotating in a left direction, we have to firstly switch on the motor, and the direction should be anti-clockwise. And we will be using another motor, which is a DC motor. We will change its pin configuration. We will add new DC motor configuration. It's a 2-pin mode, so we will select 2-pin, and the pin 1 is 18 and the pin 2 is 19. Add the motor setting. In the motor setting, we can see the pin configuration and the switch. So we are turning on the motor. The switch will be turned on. The direction will be clockwise. Then we will add a delay. Now we will turn off motor. So DC motor, we have to change its pin configuration. For motor 1, we have selected DC motor P2 and P4, and we have to turn off. So we will select turn off. Done. And then for motor 2nd, which is P2 and which is a P18 and P19. So we will turn off it. Yes, it's done. Now we will connect the flow. Display left motor like this. Now we can understand that if the received data is equals to A, then it will display the left. What if the data is not equals to A? Then it will check another conditions. So we will use another directions using a compare string. Check if equal the received data check if it is equals to D. We will be using if node for checking the condition is true or not. So the condition will be result, and it is done. If the received data is equals to D, then it will display right. Then it will display right. Now we will connect the flow. For rotating car in the right direction, the motor 1 should be in a clockwise. So we will firstly take motor, DC motor. We will change its pin configuration. So motor 1 is our P2 and P4. It's turn on. For rotating in a right direction, we will be using the direction in a clockwise. So here it is done. And now for motor 2, the pin configuration is 18 and 19. It's turn on. The direction will be anti-clockwise. We will add a delay. Now we will turn off the motor. Both the motors, so motor, DC motor. We have to change its pin configuration. We will select motor P2 and P4. We will turn off it by selecting here, turn off, and it is done. And then we will add another motor, DC motor. Or we can just copy paste that, but we have to change its configuration, turn off, and it is done. For forward direction, we have to compare with an integer w. We will using a compare node string 1, which is a received data. It has to be compared with an key w, and the output will be the result. If node is used, the condition will be equals to the result. If the received data is equals to w, then our car mode and then our car will rotate in the forward direction. So it will be displaying forward. Forward. Done. Now we will connect the flow. We will be connecting the if node with the compared data. If result is equals to w, then it will display forward. You can just copy paste it. Now we will change its setting. Firstly, we will check the motor. Yes, it's a motor P2 and P4 for the first two motor, and we will turn on. For forward direction, both the motors should be in a clockwise direction. Yes, it is. And then for motor second, control plus V, we will change its pin configuration. It's a second motor, so we will be selecting DC motor P18 and 19. Turn on motor, the direction should be in clockwise for forward. We will connect the flow, add a delay of 1 second. Now turn off both the motors, P2 and P4, turn off. You can just copy paste that. Now it's done. Connect the flow. Now we will use another compare string for backward direction. So if the received data is equals to S, then it will provide an output of result. So if result is equals to S, it will display backward. So our car will rotate in a backward direction. So we will be using if, we will change its setting and the condition will be the result. It is done. Display backward. Done. For the car should be rotating in the backward direction, both the motors should be in anti-clockwise direction. So let us do that quickly. We will add DC motor. We'll change its pin configuration. For motor 1, it's P2 and P4, and switch turn on. For backward direction, it should be in anti-clockwise. DC motor P2 and we have to change its pin configuration. The direction should be in anti-clockwise, so do it. Then now it's done. Add a delay of 1 second, just like the previous case. Then turn off both the motors. And just copy paste that. It's turn off. Done. And for second motor, we will be copying the node and pasting here. And here we are done. So we will connect the flow. If the received data is equal to W, then it will display forward direction. And if it is not equal to W, then the S condition will be comparing the received data with S for backward direction. So let us just summarize all of this in one shot. When we turn on the Bluetooth receive, it will produce an output which is a received data. Then the compare string will compare the received data with an key A. If it is equals to A, then it will display a left. It means our car will rotate in a left direction. Then we have two motors, which is DC1 and DC2. And its pin configuration is 2 and 4 and 8 and 18 and 19. Both are turned on, and then we will add a delay for 1 second. Then both the motors are turned off. If the condition, the received data is not equals to A, then it will compare with D, and in this way the flow goes. Let us check and verify, is it right or is there any error? So there is no error. Now we have to upload Now we will see the port COM3, and now we will be uploading. and it is uploaded successfully. It means that there is no error. So let us see the output.